Okay, pardon my messy bench. I'm getting ready to install my new board. Taking a few things apart here. These are my temperature probes that will be installed again. This is my anti-spark XL90. So we're gonna disconnect it. I already started taking some of the components off, but we're going to disconnect it. And it's a good tight fit. Then I like to discharge the capacitors. There's a number of ways of doing it. You can hook up a light bulb. But I'm just going to, I think Ian from Speedy Fit Feet does this as well. I'm just going to hit the on-off switch. Okay, so the capacitors are now discharged. So when I start working on a board, I just don't want to get, I've already been fried once. I've already taken the liberty of going around and cutting all the silicone. And I like to take a little pair of needle nose pliers and just kind of, don't really pull on the wires themselves, and kind of wiggle them back and forth with a little pair of pliers like that. Same way for up here. I've already kind of severed the insulation or the silicone. I put some color coding on here just to kind of let me know where the cables go, but I've done it so many times now. But this one has a little yellow on it, a little black, little kind of a turquoise color. And this last one here, the 5 wire, is my Hall sensor. There it comes. So just be careful. You don't want to pull on those wires because they're really, really thin. I think they're like 24 or 28 AWG, so they can break really easy. Okay, I did take one of my bullet connectors apart, but I've got a lot of shrink wrap on here. And I don't feel like taking a knife and cutting through here because I want to save as much of this wire as possible. So that's the pain about shrink wrap. So I like to use a heat gun and soften it up. This is going to take a few times because you can't get it too hot because then you can't touch it. But then I just get in there with my fingernail and start peeling it. You can see how it's starting to come apart. This stuff cools pretty fast, so you gotta work kind of fast. But there, we're starting to get the bullet connector exposed. Okay, I've removed the bullet connectors. I still need to do the ones on the wires that are coming directly from the motor. Board's about ready to come out. Just be careful of your little screws so you don't lose them. And then the little rubber gasket. That's always fun to put on. It will be stuck down inside of there very carefully. Alright, so somewhere in there is bad firmware. This one I still have a Bluetooth, as I had a few of these different boards, one I had ordered from China, so I still have a secondary Bluetooth module, but I'm thinking of possibly sending this one back to Jason so I have a spare board and having him reflash the firmware. So other than that, I guess there's nothing wrong with that board. Okay, and this is this little paste down here that you want to make sure that you have plenty of that. That's that thermal transfer paste. So when the board, you can see some residue there, when the board sits on these pedal hangers, it also acts like a heat sink and transfers the heat. So I'm going to be applying more because you want it to, when you put this down on here, you want it to squish out. Actually, this one wasn't completely filling the void, so I want to make sure I fill all the void. So I'm going to put ample material on there. Okay, my new board is in place now. I've applied this Duralast. It's a thermal heat type paste between the heat sink and the pedal mount before I screwed this on, and it squished out. So it we got a really good bond right there. So I cut the insulation back and I've bent the wire in half. That way when I put my bullet connector on, it's going to be a much tighter fit. So, but you can just see, I mean, these are monsters. There's not going to be any resistance at all. Okay, I'm preparing my bullet connectors. I'm filling them with 60-40 solder, and then I'll be putting the wires inside. I'm using a propane torch, and I made up this little wood block. I didn't want to take any heat away. I want all the heat to be transferred to the bullet connectors. If you put them in a vise, then the vise becomes one big heat sink. So we're just kind of filling the cavity until it comes flowing out the hole. You can see the little hole right there. Yeah, it just popped out. I like the propane torch because you can get it really hot fast. Plus these bullet connectors are a great conductor of heat. So I'm going to start tinning my wires in the same fashion before I insert them into the bullet connectors. I want to make sure I penetrate all the wire strands. The most difficult part about putting on bullet connectors is this gets really hot. So I've got this octopus kind of, it's called quad hands, and I've got you can see the wire going into the bullet connector. So as I heat it, I'm going to take this particular hand of the quad hand and raise up so that wire goes all the way down inside the crevice. or the divot. So we're going to heat it up again. Now this might take a little bit longer because we're now holding, it's kind of like this clamp is going to take away from some of the heat. There, it's starting to go. Now I see flow at the top where the wire is coming in, so I know I've got a good good bond and not a cold solder joint. Okay, it's cooled down enough. There's one bullet connector, and we got a good healthy flow of solder all the way around it. So I'm going to proceed to the other ones and do just the exact same thing. So now I'm going to take the bullet connector and make sure that the wire is all the way down inside. I'm going to put it back in my block here. So I'm going to heat it up and use some downward force with my needle nose pliers. If the wire moves, that means it wasn't down all the way. There's only about 3/16 of a divot, maybe 1/4 of an inch. Okay, the solder's melting on the top. That means it's all the way through. It moved ever so slightly. Not enough to concern me, but I'm glad I did it. Okay, I just applied the heat shrink to the bullet connectors, and I've been doing a little bit of heating. Don't want to bore you with this, but you can just see how beefy these connectors are. Now we're going to change out the XL60 connector to the spark arrestor XL90 connector. You can see how much bigger it is, and that will connect into there. And also we need to change out the bullet connectors so they now fit the larger 5.5 bullet connectors. So here we go. We're just going to snip the ends. I want to save as much wire as I possibly can. Same way here. Now again, I've already discharged the capacitor, so it's a good idea to do that. Okay. So now we're going to strip our wires. Again, I'm going to be folding these wires over in half, so they accommodate my larger bullet connectors. So I'm going to strip them back quite a ways. Now this is still a 14 gauge, but it's a silicone. So normally I would go 14, but I'm going to drop it down to 12 on my tool here. Which worked out pretty good. As you can see, there's no strands that have been inadvertently cut. This is a really good tool. You can see it has all the different AWG wires, but this is just with this added insulation. I wish they would do all the motor wires with the silicone too. If you look at it real close, these are rated at 200 degrees Celsius. So where the other wires, they don't have any rating on them. So kind of give you an idea, the wire is peeled back just enough to set in there. Now these kind of are an open-ended connector, so when we solder these, we need to puddle the solder so to let gravity kind of let it settle down in there. Now I'm going to mark my connector just to be on the safe side. That's going to be the black negative wire there. Let's put it on the other side too. Can't be too safe when connecting up this high of voltage. Double check configuration. As you can see, there's no way that you can put the other way. It won't fit. It's like a jigsaw puzzle, but it's a good idea. Make sure you get the wires in the right spot. Now I'm going to use a soldering gun to solder my connectors. The propane blowtorch will melt the plastic. So we're going to flow some solder inside here. I'm going to bring the solder right up to the edge. I'm going to go from the back side and make sure that we have full contact with the terminal. Okay, here's the second terminal to my spark arrestor XL90s. So now this little protective cover just slides right over the top. And fastens right on in. So now I'm going to go down the line and tin each one of my motor wires coming off the main board before I put them in the bullet connectors. Now here we'll use a torch again. Okay, now that our wires are cooled and everything is tinned, we're now going to slip these into our bullet connectors, the actual female portion of it. These have already been filled with solder. Okay, now I'm sliding up my protective heat shrink. So I'm going to heat my heat shrink. Okay, so I've cut 3 sleeves. This is this 1900 degree high temperature material that I've tested with a blowtorch. So I'm going to slide each sleeve onto my wires coming off of the main board. Okay, so we have our sleeves going over our bullet connectors. And I'm quite pleased with the way they're kind of setting down inside there. Okay, so now I'm going to, I've got my 2 temperature probes. One channel will be going into the motor wire connectors. There really isn't a major decision on this. I think I'm just going to use the one that's closer to the back. It'll allow me to feed my wire. So we're going to slip in the temperature probe. All right, I'm going to reconnect up my power supply coming off my packs to my main board. Again, these are the spark arrestor. So when I reconnect, there is no spark whatsoever. So I really like those. I then drilled another little hole down here in this little plastic tab, ran a wire tie through. It just kind of keeps this bullet connector flat to the surface. Okay, everything's been refastened. You'll see here's the temperature sensor that's coming off the motor wires out of the axle. The other temperature sensor is buried inside these cables here. You'll see it right there. So I've made the wires, being I've got all these protective shields going around all the wires, trying to keep them separated too. I've made a little plastic flap to go over to hold everything in place. And then I've drilled a little hole. I don't know if you can see it. So I've got a wire tie going through this little plastic tab that comes up. So I drilled a hole through that little shield. So that just kind of keeps everything kind of in order. Okay, everything is back together. We're ready to put the side cover back on and the pedals. Kind of let you see some of the different things that I've done. I've had to remove posts to be able to get my fan in. There's another post that was down there, because this area here is where my fan goes. I had to make a special little plastic bracket to hold the wires down there so they wouldn't come in contact with the fan. I've had to channel out some plastic up here so I could get the connectors up here. Again, because of the fan. These are the new shields that are good up to 1900 degrees. At least when I put the propane torch on it, degrees centigrade. They're not going anywhere. Down here is my little temperature probe sitting right next to the motor cable connector. And again, there's another probe that's up underneath. So I needed to keep all these wires with the bullet connectors the size that I used. Everything wanted to kind of raise up, so I made this little plastic shield to kind of keep everything tucked down tight, and I had to drill a little hole for the screw. A lot of my wires are now connected to some of the little plastic tabs coming out. I've drilled holes through them to hold things down. I did that down here. This is my XL90 spark arrestor. I wanted to keep it kind of tight as well, so we've got that. I've got a lot of plastic shielding coming over the top. All of this cannot go up here. There just is no room. I've just got too many wires going on, but it's nice and flush and it's protected. Plus, a lot of these wires are used for my temperature data logger. There's the new board. Everything's been siliconed in place.